In this question, we are given y equals under root a square plus x square plus under root a square minus x square divided by under root a square plus x square minus a square minus x square. And what we need to prove that dy by dx equals minus 2a square over x cube times 1 plus a square over under root a raised to the power 4 minus b raised to the power 4. Now, before applying differentiation, we will first simplify this, and we'll simplify this by multiplying and dividing the numerator and denominator with the conjugate of this. So on multiplying and dividing the numerator and denominator by this, what we get here, that in the numerator we can say that it's forming the identity of a plus b, right? This is a plus b into a plus b, which is a plus b the whole square. So that results to give you what? This is a plus b whole square, square of this. So this is a square. That means we can write without under root plus b square. The square of this will be same without root. And this is positive 2 times a into b, well, keeping in mind that it is under root. So this is, I can write with a single root. This is a into, and this is b. That whole divided by, and what's the denominator? In the denominator, we can observe it is in the form of a minus b into a plus b. That means we can write this as a square minus b square. So the square of this will be the same thing without under root minus b square, and minus of this will be what? This will give you minus a square and positive x square. Now what things get cancelled here? That is positive a square, negative a square get cancelled, and above it is positive x square and negative x square get cancelled. So in the numerator, what we are left with, a square plus a square, that is 2 times a square plus this is 2 times, simplifying this, what we are getting this as, applying the identity of a plus b, a minus b, this is a raised to the power 4 minus x raised to the power 4, and that whole divided by this 2 times x square. Now we can cancel this 2 as well in the numerator and denominator. So these two, further this 2 can be cancelled. This is taking 2 common, we can cancel this. Now we are left with y as this. Now by writing them separately, we can say that this is a square over x square plus this whole under root a raised to the power 4 minus x raised to the power 4, that divided by x square. Next, we are going to differentiate this for the first part. First, we'll write on the left hand side, we have dy over dx. Well, this being the a square being a coefficient, this is a square, and the differentiation of 1 over x square. Well, 1 over x square is same as x raised to the power minus 2. So it's minus 2x raised to the power minus 3 is its differentiation, which I can write like this also. So we can write the differentiation of this as minus 2. So I'll write minus 2 over here and x raised to the power 3. And for this part, we'll be applying quotient rule. So you can see the numerator derivative is, this is root x. So I'll be writing this as 1 over 2 root x, right? So this is 1 over 2 times root x. Well, x is a raised to the power 4 minus x raised to the power 4. And by chain rule, it is minus 4 times x raised to the power 3. That multiplied by the denominator, which is x square, and we should give a minus sign here. Next is the differentiation of this, which is 2 times x, and the numerator, that is a raised to the power 4 minus x raised to the power 4 as it is, and this whole divided will be the square of the denominator, which we say as v square, that is x raised to the power 4, right? We have this, so its square is x raised to the power 4. Now next is to simplify. I can see that this 2 and this get cancelled by 2 times. So next we have in the numerator, well, this is what we have, which we have got 2a square over x raised to the power 3. And if I simplify this, so if I divide this by x raised to the power 4, this is x raised to the power 5. So I can see that we'll be left with 1x, and that whole divided by this is a raised to the power 4 minus x raised to the power 4. Now on dividing this, we get this as 1x get cancelled here. So we are left with 2 times a raised to the power 4 minus x raised to the power 4, and below we are left with x cube. So this is minus 2a square over x raised to the power 3, And on this part, if I take LCM, well, LCM is going to be product of these two denominator, that is x cube times under root a raised to the power 4 minus x raised to the power 4. Multiplying this, what we are getting? This is negative 2 times x raised to the power 4, and this multiplied by this, the under root will get cancelled. So this is 2 times a raised to the power 4, and negative 2 and positive, negative is positive. So it's positive 2 times x raised to the power 4. Well, in this way, this get cancelled. So this is x raised to the power, negative and positive 2x raised to the power 4 get cancelled. Right. But we can see that there is a plus sign there. So there was a plus over here. This is plus. Now, if I take what we can take common here from the remaining term, I can see that we can take this as common. So if I take out negative 2 times a square over x raised to the power 3, if I take common, I'm left with 1 over here, and this is plus because minus is taken common, right? Minus is taken common. So this, you can see that we are left with a raised to the power 2. Why? Because I have taken a square as common, so it was a raised to the power 4. And this divided by, I have taken x cube as common, so we are left with a raised to the power 4 minus x raised to the power 4. So I can see this is what we need to prove.